start whenever.
All right, welcome everyone. So what we're going to do today is review the basic logic gates. Our logic gates. And as you might recall, there's only a small handful of gates that we can use to realize any number of Boolean functions. The first that we'll review is the inverter or the NOT gate. Here is the symbol that's commonly used for an inverter. Now the inverter has a single bit input, we'll call that X, and a single bit output that we'll call Y. And if we want to look at the operation that the inverter does, we can see that via a truth table. So I'm going to draw out a truth table and list every possible combination of inputs and outputs. So for the inverter, if the input is a logic low or 0, the inverter inverts it. So the output will be a 1. Now for the other case, if the input is a logic high or 1, then the output will be a 0. The second gate that we're going to look at is the AND gate. Now the AND gate can take multiple inputs, but it boils it all down to still a single output. In this first example, we're going to have two inputs. This time we'll label them A and B, and then our single output Y. Let's draw our truth table again, and let's enumerate every possible input combination for our inputs, and then the corresponding output for Y. All right? So how does the AND gate work? If both inputs are false, 0, 0, or logic low, then the output will also be a 0. If the A input is a 0 and the B input is a 1, then again for the AND gate, the output will be a 0. And for the other case of A equals 1 and B equals 0, we again will have an output of 0. And then for our final case of A equals 1 and B equals 1, then our output will be equal to 1. Right? So another way to summarize the functionality of this gate is to say if A and B are both true or logic high or a high voltage, then the output Y will also be a high. Conversely, we could say that if any of the inputs are 0, then the output of the AND gate will be 0. That's enough of a segment.